you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says "Pay me now." And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Hey everybody, and welcome to another episode of JavaScript Jabber. This week on our panel we have Joe Eames.
Hey everybody.
Aimee Knight.
Hello from Nashville, Tennessee.
AJ O'Neill.
Yo, 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 driving at you live from the road.
I'm Charles Max Wood from devchat.tv.
Better than the shower.
That's yes. Somebody should do that sometime. No, never mind.
He'll never live that one down. Okay. A little too rowdy today. We all need to settle down with myself. Too hyper. Being quiet. Bye.
Gotta unwind after that keynote, huh?
Yes.
We also have a special guest this week, and that is Gareth McCumskey. Gareth, you want to say hi?
Hello, everybody, all the way from Cape Town in South Africa.
Do you want to introduce yourself real quick?
Sure. I'm currently obviously living in Cape Town, South Africa, working for a company called Expat Explore, leading the dev team there. And we have basically over the last year to year and a half now been exploring deving in the serverless and microservices realm. So that's kind of why I'm here tonight.
Nice. And you actually emailed me and mentioned that we should talk about serverless.
Yeah, I noticed I was listening to a few episodes, been listening to JavaScript Jabber for a while, and the topic keeps coming up. You know, somebody in the one of the topics will talk about serverless. And I think I remember hearing you say, Charles, that we should probably get someone to talk about it sometime. So I thought, well, if the topic needs to be talked about, maybe I can help. And yeah, it just kind of went from there.
You were thinking, there's way too many servers on this show. Serverless.
Yeah, something like that. Now, one thing that I've run across, though, with serverless is that there's a little bit of confusion about what it is. So usually when I talk to people about serverless, they're thinking, oh, Amazon AWS or something like Firebase. But if you really look at them, they're backed by servers. They just are a service that you can connect to for one thing or another, right? But then other people are bringing in like microservices on Docker, and they talk about that like it's serverless. So where's the line?
Well, serverless is actually a technology that's been around for quite a while. It's just lately the buzzword has been sort of, gaining traction. People are hearing the word serverless and talking about that. But pretty much since about 2008, Google were like the first guys to really hit the sort of serverless side of things, back when it was still called Platform as a Service. And that's essentially the Google App Engine. The whole idea of serverless, though, is to kind of take that whole layer of deployment and servers and worrying about things like an Apache server and Nginx and all the kind of stuff that devs generally kind of want to avoid a lot of the time, and have something that you can throw your code at it and it'll spin it up, create your load balancing for you, manage that whole process, and do it in a way that a developer might not understand the technology, but do it in a way that makes it performant, makes it reliable, and so on. And that's the short version of what serverless essentially is. But over the years now, it's just blossomed out into multiple different types. With the, like I said, the App Engine and AWS Lambda and so on. So it's just solving that whole deployment problem for developers, essentially.
So all of those things that I mentioned are serverless then?
Well, Yeah, a lot of them are. Firebase, for example, is one of the sort of serverless solutions that you try and set up a service as opposed to setting up a machine to do things. So Google has all the tech in the background that you push a configuration file at, and maybe a zip file with some code, or point it at a Git resource, and it knows where to pull your code using the config file to know how you want that to be set up with the roots or a database backend, perhaps. But you don't have to go and worry about the actual CPU and the RAM and the hard disk and any of those elements that you often have to worry about if you're setting up an EC2 instance on Amazon, for example.
So, so then the hotly contested one that I hear debated the most then is a microservice on Docker.
Yeah, the difference is there that for the word serverless is normally pointed at the developer. So if you're the DevOps guy busy setting up the actual machines, running the Docker instances, managing that process for you, it's definitely not serverless, because you're the guy that actually has to worry about the RAM and the network interfaces and all that configuration. But for your developer in your team who's writing your code, who's then deploying onto your sort of Docker infrastructure, to him it's essentially a serverless setup, if that makes sense.
Yeah, that makes sense.
So another term that's gotten thrown around is no backend. Is that, in your mind, currently related to serverless, or is that separate?
Sorry, what is that again? I missed the first part.
No backend is another one of the buzzwords that's been thrown around.
Node backend.
No backend.
There's an element to that as well. So from my point of view, from what we've been doing at Expat Explore, we don't have a no backend solution. Our backend is just running off of AWS Lambda, essentially. So there is no infrastructure for us to manage. We throw little bits of code at a backend, and we don't necessarily care about what the machines are that run that to a degree. We just want to have something where you push a request at a function and it gives you data back, essentially like an API. But the no backend solutions are the types like the Firebases and so on. We essentially just deploying these services that Google Cloud, for example, makes available for authentication, for data storage. So you are talking to APIs, and you essentially don't have to worry about a backend. And that's what Firebase has pretty much made very popular from a serverless point of view.
So when people say serverless, what they mean is no DevOps. And when people say no backend, what they mean is you write all the code in the front end, and you don't push code to the back end either. Is that what you're saying?
Yeah,
what about
pretty
those
much.
server functions, though?
Sorry, what do you mean by server functions?
Sorry, the cloud functions or stuff like that when you're just storing your data.
Yeah, I mean, a lot of the cloud providers, they have these data services. AWS has the DynamoDB things where you communicate with your database, your data backend via API. Google has essentially the same things with Cloud Data Store. So in those cases, you don't particularly care what the infrastructure is like or what the actual machine is that's running that for you. You're just telling it, here's my data, keep it for me, and I'll eventually ask you for it back again. Whereas Firebase takes it one step further, and you're saying things like, I would like to authenticate. I don't care how you do this. I just want to authenticate with Google. Here's what my users give me on the front end. Authenticate this through, Google Login Provider, Facebook, or any of these other service providers. And it just spits back the, success responses for you. It essentially ends up depending on what you're trying to build. If there's a service that can provide you with the functionality you're looking for from a front end, then you don't need to worry about a backend at all. But then you have a solution on the other side, like an AWS Lambda or even Google Cloud Functions, where you can write small snippets of backend code and keep things relatively simple without worrying about the stuff that's running it in the end.
Right. So those backend systems are things like you mentioned Lambda. There's also Azure Functions. I think IBM has something built into Bluemix. I mean, there are a lot of different solutions out there that do essentially the same thing.
Yeah, and the great thing about that is that we now have options in this space. Initially, it was essentially AWS Lambda was giving you the only provider of this kind of microservices serverless option. But now with Azure Functions, that means you can spin up your functions there as well. and Google Cloud Functions, which is still in beta right now, but they're very quickly reaching sort of production stage as well. And I think their plan is first quarter of next year to be production ready on that side. What's nice about that, though, is that even at Expat Explore, we're looking at trying to find ways to straddle two vendors. So if something happens with AWS, we've got a way to fall back to Cloud Functions or Azure Functions to continue to serve customers making front-end requests to our back-end microservices.
So how do you start thinking about this then? I mean, AJ brought up the no backend, so you go use something like Firebase, or you cobble things together from the database systems you mentioned, maybe pull in Auth0 for authentication, and then you do stuff here or there to make the rest of it work. Versus maybe pulling something in like Firebase that kind of does everything for you. How do you decide which way to go?
Well, for my case, I'm generally the person that likes to reuse stuff that's already out there. I hate reinventing the wheel the 17th time. Been there and done that. So if there's an existing service that can kind of do these things for me, I'd rather use what they have. Not to mention that they've probably got a lot cleverer people than I am to be able to do these things the right way, make it secure, make it performant, and so on. So if there is a way for me to reuse the sort of authentication mechanisms in Firebase or other services like that, I'm generally going to go for that. It just makes my life a lot easier. The other thing is, though, with my use case, for example, we are redeveloping what we already have onto serverless microservices. So in that case, if you're going in that route, the way to do it, we found that that's been quite easy, is essentially take our front-end site, for example, is what we're doing right now. We're taking components off of that and re-implementing them onto a sort of microservices backend and writing the front end to talk to that. One simple example is we have a reviews component that sits on our site for our products. And that's a relatively simple system that sort of stands alone outside of the rest of the site, and is quite easy then to make the backend stuff sit on an AWS Lambda function, for example, where you just request review scores for a product, and that comes back through AJAX requests from your front end. And you kind of just go through that process of we've taken the process from going from the sort of simple things like a review section on a product page to the more complex things, where to the point now where we're converting the entire product page, all the content for an entire product page, into a backend request from an AWS Lambda function. So it just means you taking it progressively deeper and deeper in that route. Yeah.
So I kind of have a question I'd like to ask here before we go further. I feel like a lot of times, I don't know if this would be something like for someone more advanced, but maybe people who are like, junior or mid-level, or maybe even people advanced. But a lot of times it seems like a lot of people, if they're going serverless or something like that, they kind of sometimes assume that it's always going to be up, and that's not always the case. Like even AWS has failures in different parts of their infrastructure. So when you're building things out, what kind of stuff should you consider that might be different if you're managing this stuff yourself?
So if you're trying to build your own sort of serverless solutions, this is getting to sort of the DevOps side a little bit if you're setting things up through Docker containers and stuff. It's in there is just the good practices that you get from, even if you just run simple EC2 instances with load balanced setups across multiple regions with AWS. But the one, like I mentioned before, the one nice thing if you're using the serverless microservices stuff, and even the stuff that's not based on microservices, is most of these vendors all kind of have the same product that do the same thing, and they can run the same code. And what's useful is because you're, on AWS Lambda, your functions are generally quite small, maybe a couple of hundred lines of code, if that, and tweaking that code to work on a different vendor. If you're going from an AWS Lambda to Azure Functions, there's very little you need to change between the two. So it does give you the option to fall back between different vendors, which is kind of a cool way to do it. So even if AWS, disappears off the face of the planet, you've still got a place like Azure Functions that can take it over for you if need be, which is kind of cool.
That's interesting. I hadn't thought about them being similar like that because, yeah, in my mind, they would be like the APIs would be vastly different.
The cool thing is there's not really an API involved. You basically have a little piece of code that accepts some basic inputs, and that's what you need to change between the different vendors. In front of that, you might have a URL string that you point to, and that's again the only difference. But you can point your domain name to a different URL relatively simply, so that kind of information gets hidden anyway. So the only difference then is the actual data that gets sent into a function, and that is essentially 2 lines of code that needs to get changed to handle that input correctly between different vendors.
Yeah, I've done Amazon AWS Lambdas. I keep winding up going to the Microsoft events, but I just haven't played with functions, Azure functions. But yeah, so their API last time I deployed anything to Amazon AWS used Node 4, which is kind of an old version, but it's Node, right? And so then you just structure your arguments a certain way, and then you tell it to point a URL at it, and then it gives you all the data that you'll need in order to do the work based, and that all comes off of the URL. So the rest of it is just programming JavaScript. So if you know Node and you know what, how the Node APIs have changed since Node 4, if you're using a different version of Node, I mean, that's all you need to know in order to deploy most of this stuff.
Sure. And the cool thing is they recently, a few months back, upgraded to Node 6, so you can actually run Node 6 functions now.
Yay!
So that's a pretty nice change. Yeah. I'm really looking forward to Node 8, async await for the win. But that'll come eventually.
What about using libraries from NPM?
So the cool thing is that when you deploy these things, you don't actually have to push your Node modules up to AWS Lambda. So it's not going to be hundreds of megs of code that you're pushing up, because once you send the code, it takes the package JSON file with it, and it'll actually pull the modules for you on the Lambda itself. And the other thing is, that doesn't affect the time for. So maybe I should backtrack a bit and go into a bit more detail about actually how the sort of Lambda system functions and how they actually execute, because that'll also answer the question a bit about the Node modules. So when you push code at AWS Lambda, you've got your function just sitting there as a piece of code, but it needs to run on a machine. Obviously, it says serverless, but it's actually a machine there at some point. So on AWS's side, they run Docker or a Docker equivalent, because they always make their own things happen. And they need to spin up a Docker instance to handle your function when it gets requested. So instead of when the request comes in for your function, it now doing an npm install to get all the modules, it's already done that. The code is already sitting in an S3 bucket for you, ready and waiting to be deployed into a new container. And this can take, it depends which of the languages you use, but for Node, thankfully, it's about 10 to 20 milliseconds at its worst that I've seen. They've really improved it over the last few months. And what's nice about that is, even if it's been days since somebody called your function, within 10 to 20 milliseconds, your Docker instance is up. And that seems a bit slow at first. But if somebody comes back again within an hour, the same instance is reused. So then that's 1 millisecond of response time before your function can execute, which is pretty nice. And at that point, you've got your Node modules ready and waiting. It just throws the code into the container, executes the data that gets sent into it, and does whatever you tell it to, whether that's a response to an API call, writing to a database, whatever function, sending an email.
So that's another question I have is, where are all the services stored in this case? Because the email send doesn't happen on Azure, right? And the database storage doesn't happen on the Azure function or the Lambda. So where's the database and where's the email?
Well, this is the other component of the serverless side of things, is that you can set up a service in AWS or whichever vendor you're with. You can even go cross-vendor for the data storage, which is something we're also looking at. But you essentially set up the service. So if I want to store some data in a NoSQL style storage, I can use DynamoDB for that. I don't have to worry about the actual machine. It doesn't sit on my function. It's called through the AWS API. And there's similar things with Google Cloud's data store and those options as well.
Yeah. And
so to me, that sounds like it's increasing the complexity. Like I now have more keys to keep track of, more things, more interaction points, more points of failure. I mean,
thankfully,
tell me more.
Well, thankfully, the nice part of it is that if you are using AWS Lambda functions and you make a call to DynamoDB, their NoSQL data store, the network calls are local. So usually it's in the same data center, and otherwise it's within the same region. So those network calls are very short. The other side is that sorry, I'm just trying to remember the rest of the question.
So as far as the keys go, I can jump into some of this because what I set up was a call to Slack. So I set up basically a Slack automation tool, and I used a couple of AWS Lambdas, and yeah. So essentially, they allow you to set up secrets in each Lambda. So you just set that up, and then it does what it's supposed to do, and so that was pretty easy. You know, yeah. If those secrets change, then you have to go swap them out, right? But you know, if you're using an API key and then you're using that to send out emails through SendGrid or similar, then you know, you just put your SendGrid keys in there or your username and password or however you authenticate against the SMTP server, and then off you go. And then, you know, as Gareth said, if you're using SMS or, you know, which is Amazon's mail service, you know, then that's all local and goes out through Amazon servers.
The other advantage is that to be honest, the secret side of things, if you think about it, you're not actually adding any additional secrets to what you need. If you're running on your own server, you still need a username and password for your database storage, whether or not it's local. That doesn't change. You still need some credentials to access a data store. The other side, though, is if what we use at Expat Explore is a framework that has become kind of incredibly useful for us called serverless.com. It's what this helps you do is manage that whole resource allocation process. So you create a function, but it needs to interact with a DynamoDB table. Well, setting this up using the serverless framework, it manages that kind of integration quite nicely for you and the permissions to access things. So you just set up the sort of permissions you want in a configuration file to a Lambda table. And the serverless framework will help you make sure that's set up properly on the AWS side or on Cloud Functions or Azure Functions. It's vendor neutral, which is kind of cool as well. So there's very little in the way of secret management there because your AWS API user that you set up to install these functions on AWS to deploy them into AWS itself has to have permissions to access DynamoDB. So there, in fact, it's reducing how many secrets you need to worry about. One thing we found useful, though, is in our deployment system, instead of trying to store these secrets in code, which is obviously a bad idea, we try to do this in our environment variables. So when we deploy to AWS, we're pulling our deployment system pulls the environment variable out for the credentials we need to use to AWS instead of having that stored in code, which helps us just manage our secrets a bit better.
Yeah, I would hope that nobody here listening puts their secrets in codes, but I know that those people exist.
Well, especially if it's all front-end code, and even if you obfuscate it, it's still not a good idea.
Yeah, the interesting thing was we found interesting ways to work around issues with front-end secrets. I don't know if this is the right amount of detail for this specific show, but one of the issues that we had was we're trying to move away from having a backend that builds pages. We're trying to have a front end that will dynamically load DOM or manipulate DOM in the front end. Based on Lambda functions returning data. So the interesting problem there is how do you get somebody to authenticate, or how do you get an API to request data using credentials without exposing those credentials to everybody that comes to your site? Because even obfuscation, like you said, is pretty much useless. So the idea that we hit upon was that we have, for example, a public credential set, which works on our authorization side. So with these functions, Lambda, AWS Lambda especially, they have an authorization and authentication system for API Gateway, which is their layer on top, in front of your Lambda functions that you can use to make API calls. And the nice thing about that is that it can handle authenticating and then using JWTs for authorization from that point on. So feel free to stop me at any point if you want me to clarify. But the idea is that we have a public a username and password set that we use to authenticate with, and that user only has access to publicly accessible data that anybody can see anyway. So if it makes a request, we can see on the Lambda side, does this person have access to this data? And if yes, send it back. And if anybody wants access to the non-private data, they have to use their own credentials to authenticate anyway. And that person has the permissions to view this private data. So the credentials that are being passed are not publicly accessible to anybody on the site. Only they know it because they have input those details onto the front end. And that's what then authenticates with the Lambda to determine, can we give this person that's viewing it the information that they're asking for, if that makes sense.
Makes sense to me.
So I'm kind of interested to hear what your favorite serverless technologies are. We talked about a lot of different ones. What are your preferences?
Well, these days I find myself more and more building stuff based on microservices, but I do still have a few freelance projects that I tend to work on that sort of follow the more traditional, monolithic SOA type model with, an Express app and so on. I found when it comes to those types of apps, one of my favorites is actually Elastic Beanstalk on AWS. It's a pretty cool feature where you can point a Git repository at an AWS service and tell it, please run this app, and it'll automatically say, it'll automatically look at the config file that you set up. You say you want two servers as a minimum for fallback and load balancing, and you need a database, and this is the SQL to build the schema for the database, and it just goes and builds things. And it manages all of that load balancing for you, spinning up additional servers in case load increases. One of those really cool features where I'm not really too concerned about what the machines are doing. It just kind of all works like magic.
So it sounds like you've built most of your infrastructure around Lambdas and sort of the do-it-yourself microservices that run there. And, you've built your authentication using some of Amazon's engines. What other services do you pull in that are either other Amazon services or non-Amazon services?
Well, one of the nice things about the Lambda system that AWS has got running as well is that it's not limited to just API calls. So there's the SNS service that AWS provides, the simple notification service. And at face value, it just looks like something you can use for when you've got an infrastructure issue that sends an alarm off via SMS to your cell phone to let you know that a server's fallen over or something like that. But it's actually quite a bit more than that, because what you can do is you can do things like an example is if you create a new user through an API call. So you submit something to a URL to create a new user for your application. Runs the Lambda function, which receives that data, adds that entry into the database. But maybe you need to do something more when you have a new user. You maybe need to send them a welcome email. Maybe you need to add them to an accounting system. All these kinds of things that come along with that. And traditionally, these kinds of things might happen in a synchronous nature, or your actual code that creates the user has to now spin off these additional functions to do these extra things. But the difficulty is over time, what do you do when you need to add more of the stuff on? You'd have to go in and edit that code again, add additional steps into this process, and that can eventually cause problems, maintenance issues and so on. But with a feature like SNS, what you can do is you create a user in your function, add them to the database, and you're finished. But you can, before you finish running your function, you can just spin a notification into a specific SNS topic to say, new user was created, here's the details of this new user, and end execution at that point. So what you can have then is you can have a send welcome email function sitting, and it's not linked to an API call. So it doesn't work through AWS's API gateway to receive API requests, but it's subscribed to that topic for create user. And it sees this notification come that says user was created, here's this user's details. And now it can create an email. It can go send this email out to the user that you wanted to do all along, or add the person into the accounting system that you need to do, or any number of other things you might want to do for a new user or new customer. And at any point, if you do want to add something else into this process, you're not editing existing code that's doing its job well. You're just introducing another function that runs completely separately from all of these and doesn't touch anything else and doesn't potentially break anything, but you can continue to enhance your system with these kinds of topic notifications. And this goes across the board. It's not just for something like SNS. You can do things with SES, the email sending service with AWS, where you can have an inbox that receives email. And similar thing, you can have a function listening to that inbox to determine what to do with this message once it comes in. The DynamoDB, which I've mentioned, has a similar thing where you can link into the table that can listen for updates or inserts into the table itself and take action when something happens there. There's a ton of these features all over the place, and you can even tie into other services. We use a CMS system for our site content that when something is published, it then hits a webhook to run another function to continue to do things. So it's pretty broad what you can do and all the services that you can tie into. And it's not just limited to API calls, which is pretty fun.
This episode is sponsored by Linode. Linode is offering listeners of this podcast a $20 credit, which is good for 4 free months at their lowest plan. Their plans start at 1 gigabyte of RAM for $5 a month. You can get your servers in any of their 10 data centers, and their high memory plans start at 16 gigabytes. Get a server running in under a minute. They do hourly billing with a monthly cap on all plans, and add-on services like backups, node balancers, Longview, etc. VMs for full control, running Docker containers, encrypted disks, VPNs, etc. You can run a private Git server. They provide native SSD storage, 200 gigabit network, and Intel E5 processors. They have 24/7 friendly support, even on holidays, and a 7-day money-back guaranteed. So go check them out at linode.com/JavaScript Jabber. So as far as static assets go, I mean, it's serverless, but the index page has to come from somewhere, and the JavaScript files have to come from somewhere, and the images and sprites and all that stuff have to come from somewhere. The CSS files have to come from somewhere. So do you just stick all that in an S3 bucket and then serve out of that, or how do you manage that part of serverless?
Yep. No, I'll go into more detail. So yeah, we do S3, but you can use any of these services. That's the other advantage that we've got as well, that we're looking at trying to do for replication of these static assets is on S3 you can store your content there, but S3 did fall over a few months back, which was not fun. But again, you can replicate this into Google Cloud or Azure. These are just static assets. They're just HTML, CSS, and JavaScript. The very cool thing is we've also been building our own sort of front-end framework, and I've forgotten what we've based it off of. Don't worry, we haven't completely built our own JavaScript framework from scratch. The idea of this is, though, we have a build environment for development, so we can dev in very nicely laid out, very nicely styled code, and then build the distributable versions of our JavaScript, CSS, and HTML. And we just host this on S3 for now. And that is a serverless way to then host your static assets, because, again, this is something we're not worried about the stuff in the back that's running or serving this content. It's just doing it for us. And it's pretty performant. We've been very surprised at how well this is performing, because we recently currently we're running on our Black Friday promotion. I know it's a bit of advertising, but we have been hit by a fair amount of traffic, and our landing page for our Black Friday has been sitting on S3 without any issues. It's just continued to serve content day and night throughout the whole process. So that's been pretty nice.
So you have it all in one place, essentially, where you can hack on the code. So you write code. It's well organized so that you can, okay, I'm going to update this microservice, and then, okay, it's doing something a little bit different, so now I need to update this other microservice, so you don't have to go to a completely different repo or anything. What does your deploy process look like then, and how do you organize the project so that it makes sense, even though these are all separate pieces doing their own job?
Well, what we're trying to follow the model of sort of following along the DDD, the domain-driven design models of bounded contexts. So to put that into something that's a bit more less abstract, we break down what functionality we need into distinct services as such. So, for example, we have the review service, which allows us to add review data and get review data out. We have a customer service, so we can add a customer to the system, retrieve customer data. We have we're a tour company, so we have a tour service to describe our tour data. And each of these are in their own repos. But within them, they have potentially they have a whole bunch of functions within them. Some with API endpoints that get called directly from our front end or other third-party services. Some functions that are linked through an SNS topic and so on, like I mentioned before. But the structure is to have each of these services be bounded by the domain that they operate in, and stick to that quite strictly. We're trying very hard to make sure we don't bleed these borders. Otherwise, that you tend to have problems then about where the boundary lies between the functionality. One nice example of that we worked on was having a user service. So you have users with their authentication details, their roles, what permissions they have for data in the system. But we also have a separate authentication service because we may also have apps that need to authenticate. So to have the two together wouldn't be a good idea because then we're bleeding those two boundaries together. So the user information is used by the authentication system, but they are still separate services as such and run as separate services. And I can actually add on to that the idea with the different bounded contexts as well. Using the serverless framework that we're using now, it actually makes this quite simple. So each of these bounded services we create as a new serverless project. So we spin up a new serverless framework project for each service. And the serverless framework lets us deploy to our vendor of choice essentially on the command line or through our automatic deployment tool. We use pipelines on Bitbucket for it. And we can just run a command on the command line, and it'll then push our functions, set up our DynamoDB tables, set up our API endpoints through API Gateway on AWS, or do the similar thing on Google or Azure if we asked it to. So that just helps us manage that deployment process nice and cleanly as well.
Yeah, I've used the serverless framework, and I really liked that part of it. I mean, you essentially npm install serverless with the -G to make it a global executable. You set it up, you tell it to create a project from a template, and then you edit it, and then you deploy it. The only part of the serverless framework that got a little bit hairy for me was the configuration. But even then, I mean, I was doing stuff that was simple enough, just making API calls back out. So you hit the URL or you make an API call through Amazon to the Lambda passing it data, and then it does its job. It makes an API call back out. But it looked like it got a little bit more involved if you were setting up DynamoDB and a whole bunch of other things. But even then, the config file was very nicely self-documented, and it was pretty easy to figure out if you understand what the pieces do in Amazon itself.
Yeah, the interesting thing is a lot of the configuration that they have there for setting up all the infrastructure pieces that you need in AWS, like your DynamoDB tables or SNS topics and all that kind of stuff, is all based on the CloudFormation syntax. So if you know AWS and you've worked with CloudFormation, that should be pretty second nature to you if you know that stuff. I didn't. I normally just go through the console and start clicking and turn this on and turn that off. So getting used to that configuration setup was getting used to that configuration setup was a bit tricky. And the serverless framework gets a little funny with you if you use it to spin up new services and then you go manually turn them off. It then starts acting a bit funny. So you tend to want to keep your working through the configuration file instead of manually changing things. But it does simplify a lot of things. It helps keep things consistent so that every time when you redeploy because you've made a change, now it's redeploying the exact same thing. It's making sure that everything is exactly as it was last time you deployed, so that it doesn't cause inadvertent errors, which is nice. I mean, having that whole deployment process instead of having to manually go to the AWS Lambda console, find your zip file that you created for your function and upload it manually. It's a lot nicer just to hit a command line, SLS deploy, and off goes your code, and it's running.
So when you deploy these, do you have some script that goes and serverless deploy on each repo? Well,
the nice thing is usually you deploy one at a time, right? Because you're making the change on one. So
Okay.
what we ended up setting up is our CI/CD solution on pipelines with Bitbucket. It has a way for us to run run things on a command line, essentially in a Docker container.
Mm-hmm.
So as we push to our master branch, for example, it'll automatically run SLS deploy on things to redeploy any changes we've made to our Lambda functions or the infrastructure or whatever change we happen to make.
Yeah, I'm just wondering if they interdepend. If the change affects more than one service, I guess you just push them both and then let them both deploy.
Yeah, that does get a bit tricky. What we try to do is we always try to make sure our services are backwards compatible, and if not, then we version them. So right now we're pushing, for example, a version 2 of our tour service, which our front end doesn't use right now. But when it's ready and we've tested it, then the guys working on the front end side, I finished writing the documents, for example, for our version 2. Send them the URL so they can read up on it. Then they tweak the front end stuff to point at the new API because that's actually changed what data gets sent and what data comes back. So it's not compatible with the previous version. And then once they're ready, they push their updates to S3, and now it's switched over to the new service. And we do similar kind of things when you have interdependencies between services. So try to keep things backwards compatible, but if not, then we try to version it so that it doesn't break automatically. You actually have to switch it over to the new version before it starts working.
Sounds good to me. What about testing these services? So you mentioned that you have CI/CD set up. How does that work?
Well, thankfully, there's actually quite a few options. At the moment, for the specifically AWS Lambda functions, there is a plugin for the serverless framework that links into Mocha. So we actually write full-blown Mocha tests to test things. It gets a bit tricky when you start talking to specific services, other APIs, third-party APIs. You obviously don't want to start putting things into a production database when you're running your test scripts. So we end up using tools like AWS Mock, for example, which is another NPM module. It just helps us intercept these calls to like AWS third-party services and send back a canned response that we can test for. Because we're not really worried about testing whether DynamoDB works. It usually does. And if it didn't, we can't do anything about it anyway. So we don't need to actually put something in a DynamoDB table and actually retrieve something from there either. We just need to make sure that everything before and after those interactions works with what comes back. So we end up just using mocking NPM modules to help test those features. One problem we're experiencing now is we need to speak to another third-party API service that doesn't have an already built NPM module for the mocking purposes. So we kind of have to build our own mock service for that. But the ability to test is there. It's built in. Again, part of our CI/CD pipeline is running our tests. And if the tests fail, the deployment stops in its tracks and throws an error message. Otherwise, it continues. But yeah, tests are as good as the developer writes them to be as well. So at that point, it ends up being up to the developer just to write the right tests.
Yeah, that's one of the great ironies of testing is that you have to have an understanding of what the results should be in order to, there are certainly cases where in order to write the test correctly, you would have had it written the code correctly because your understanding of the problem has to be correct.
Yeah, that's where I like the idea of the sort of test-driven development style, where you write the test for your function before you've written your function, so that when you run your test, it fails because you don't have code yet to actually do what you're testing for. But the funny thing there is that you can then write a test that always fails, even if you come back with the right things. So I often find myself running a test that comes back successful. I scratch my head a little bit, and then I tweak my test, which I know should fail, and then it still passes. So you end up in a situation where you're trying to make sure your tests are always actually accurate. But yeah.
So I actually do have a question about this. So if we're doing like integration testing, do you usually recommend like stubbing things out, or do most of the platforms that you would use like provide like a test endpoint or something you can hit for integration testing?
So integration testing is one of the tricky things with microservices in general, just because obviously everything is kind of all over the place. So one of the nice things that we've been trying to do is that with the serverless framework, for example, we can set a stage. So for our develop branch, for example, we can set the stage to be develop, and all the all our API endpoints and our functions are deployed with sort of with the word develop prefix to their names and their URLs and so on. And what that lets us do then is we can essentially deploy all of our services to AWS or any other vendor and have integration tests across the develop stage. We haven't got to the point where that's 100% complete yet, because that is actually a relatively big task. We're trying to focus on the unit testing right now to try and get that all squared away and set. But we can do sort of manual integration testing right now, the way things are set up, and it is possible to do it. Thankfully, there are many tools in the JavaScript world to help build integration tests and things like that. It's just better picking what you want. The deployment system then is just to deploy it into sort of the develop stage that's non-production, so that you're ready for when you do deploy to production, obviously.
Okay, so that answers that question. Thank you.
Mm-hmm.
All right, let's go ahead and do some picks. For you, the listeners of JavaScript Jabber, Loot Crate is offering an opportunity to save 10% on any new subscription at lootcrate.com. Just enter the promo code BRIDGE10 for 10% savings. Loot Crate is one of my favorite things. Every month I get a box in the mail. Costs less than $20, and it comes with all kinds of goodies. I have stuff from, just looking at my shelf, Batman, Spider-Man, Ninja Turtles, Back to the Future, Lord of the Rings, Star Wars, and much, much more. So if you're a geek, a gamer, anything like that, and you want cool stuff to put around your office, cool t-shirts, comic books, etc., then definitely check out Loot Crate. To save 10% on your new subscription, go to lootcrate.com/Ruby. Again, that's lootcrate.com/Ruby to save 10% on any new subscription. Enter the promo code BRIDGE10 for 10% savings. AJ, do you want to start us off with picks?
Okay, so I have been listening to more business audiobooks lately and reading business books and trying to get better in that aspect of my life of understanding successful business. And I watched the documentary about Enron, and I thought that it was like pretty enlightening, because you hear people speak like that all the time. For the way that these executives are speaking, where they're just like justifying things that they're doing, because it's just a little lie about something or other, but then it turns into a $35 billion lie. And so I recommend watching that documentary if you haven't. It is it has a scene I would recommend skipping, but other than that, I found it to be pretty interesting. And also, I've been listening to The Hard Thing About Hard Things by Ben Horowitz, and I was listening to the beginning of the book. I haven't gotten too far into it, and I'm thinking, man, this guy's an idiot. And then he kind of talks about how, and this is the wrong way to do it. And I was like, okay, good. Phew. And it's just very interesting to me to learn about why things succeed or fail, or how people recover from screw ups and that kind of stuff. So those are going to be my picks, and just business in general.
All right, Aimee, what are your picks?
Oh man, I'm trying to decide. I have a couple. So the first one, as we were recording this, because it's been a busy week, I didn't get to prep as much as I wanted to. I've been kind of reading through a post on Martin Fowler's blog by Mike Roberts, and it's just called Serverless Architectures, obviously. So I'll share that, because as we've been doing this, it's been, I thought it was pretty good, and I always like the stuff that he puts out. And then, man, toss up. So I think I know what I'm going to pick. So I am going to Belgium next week, and so I'm sure this will come out potentially after that. But I'm going to NGBE, which is a Angular conference in Belgium. And I'm going to go ahead and pick the conference ahead of time, just based on the fact that the organizers, I've spoken at
based on the fact that you're going to be there.
No, I kind of want to pick the organizers. So, it's is it? I'm going to butcher his name. Is it? I'm not even going to say it because I'm going to butcher it. Anyways, but you can go to the website, and they have just been so immensely helpful. They have covered like absolutely everything you could possibly imagine for speakers, like questions and any kind of like logistics. So sometimes when you go, like, I'm an American and I go overseas and I'm traveling by myself, it can be like a little bit nerve-wracking just trying to like make sure I've thought through everything and I have everything taken care of and getting around everywhere. But they have like covered all of that for me without me even having to ask any questions. Anyway, so I just can't say enough good things about these people and this conference. I'm really excited to go. So that'll be my other pick.
All right, Joe, what are your picks?
All right, so I recently went and saw the movie Wonder, and that was a freaking amazing movie. It was totally one of those feel-good movies, where it's like all about how this person conquers difficulties and troubles, but it was actually just a really good movie. Took my kids, very wholesome, very uplifting, really liked it. So that's gonna be my first pick, is the movie Wonder. And then my second pick is going to be a board game I recently played or picked up called Gloom in Space. And Gloom is a game that's been around before. It's basically a game where you make up stories about how you have a whole bunch of people and you're trying to kill them. And then you get these cards that give you ways to kill the people. And so you try to make up stories about how they die. And it's all very dark humor. And Gloom in Space is sort of the same idea, but with red shirts, right? So like you're killing off all of the spacemen. And you're trying to keep the other people from killing theirs off while you're killing your own off. And the cards are hilarious and lots of just really fun text about it. A great game to play with people who are a little creative. Kind of a fun game to play with your family. So there you go. Those are my two picks.
All right. Well, I'm going to jump in here with a few picks. The first pick is something that we actually talked about on the show. I was going to pick it anyway. It's the serverless framework, and it's on NPM. We kind of talked through that. But it is super impressive. It just makes it really easy to get stuff up on these platforms. The other pick that I have, I don't know if I picked this last week or not. So I'll just do the safe thing and pick the next book in the series. I've been listening to Brandon Sanderson's The Stormlight Archives, and I'm in the middle of the second book, which is Words of Radiance, and I'm really enjoying it.
Is this the first time you read it?
No, it's the second time. So I read the first two books as they came out, and then he just released Oathbringer a couple weeks ago. And so I was like, I don't know if I remember enough of the details to just jump right into the third book. And so I listened to the first two again.
I did the same thing. I reread the first two and getting ready for the third one to come out.
Yep. So I'm super excited for it. So I'll be reading that. And then I also saw an announcement for Avengers Infinity, which is coming out in May, and that should be cool too. So I'm going to pick that as well. Gareth, do you have some picks for us?
Yeah, I picked a couple of things. The first one I'm going to pick is a book that kind of goes with the topic today, especially on the microservices side. It's a really awesome book called Building Microservices by Sam Newman. It's an O'Reilly book with some honeybees on it if you look at the animal pictures. But the cool thing about the book is it's not about technology as such. It doesn't talk about Docker, and it doesn't talk about the DevOps side and all these tools that you need to use to create your microservices. It looks at it from a much more organizational point of view, like how you decide what your microservices, bounded context that we talked about are. How do you manage a team? How do you manage your dev processes, your testing processes, all those kinds of things that can make microservices kind of tricky. So it's a really cool book, Building Microservices by Sam Newman. That's kind of what helped me go down the road and try to do things kind of the right way. The other one that I picked is completely different, and it's another podcast that I listen to as well, which is one of my favorites. It's not related to dev at all, so not competition. It's a podcast called Skeptic's Guide to the Universe, and it's essentially a group of guys, the three brothers, one being a neurosurgeon, their friend, and a science communicator, Cara Santa Maria. And they essentially meet once a week, discuss sort of science topics and the latest woo crazes out there and how to debunk them and how to determine, when things might not be as they seem and how to look at things skeptically and not be, fooled into believing things that aren't true, essentially. Very cool podcast that I look forward to as well. And that's basically my 2 picks.
Nice. If people want to check out what you're working on these days or follow you on Twitter or read your blog or anything like that, where do they go?
Well, I do have a Twitter account. It's not super active. It's at Gareth MCC. And I do have my own little portfolio page that essentially just talks about stuff I've worked on in the past. It's gareth.mccumskey.com. Hope people can find that with my surname spelling. But yeah, that's the easiest way is just to get in contact with me.
All right. Well, let's go ahead and wrap this one up. Thank you for coming, Gareth.
No problem. Thanks for having me, guys.
We'll catch you all next week.
Bye.
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 Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.